In the next decade, NASA hopes to establish a long-term lunar presence, using the Moon as a testbed for future missions to Mars. The first step is sending astronauts 8,000 kilometers beyond the Moon, further into deep space than they've ever been before. They must travel at blistering speeds, through hostile environments, and encounter temperature extremes far outside the comfort zone of planet Earth. Such a journey requires an extraordinary spacecraft. Orion is NASA's deep space crew capsule. But getting into deep space also requires a massive rocket.
One of the big differences when we think about spacecraft is it's where it's going. And we can think about this question a lot like an airplane. We have smaller commuter planes. If you're going to a nearby city and you want to have that more often, you have the bigger plane that's going to go across the ocean.
The only rocket that can launch Orion is a super heavy rocket known as the SLS, or Space Launch System.
Let's just go with the basics. You have to get to a speed of about 17,000 miles an hour to get to orbit.
The energy required to go to low Earth orbit is a lot less than it is to get to the Moon. So the further away you get from Earth, the more energy or the more fuel you need to escape Earth's gravitational pull.
But it just takes a lot of energy to do that.
The SLS carries more than 2.5 million liters of highly flammable propellant to generate nearly 40 million newtons of thrust. And that creates great risk to the space capsule. Just leaving Earth safely is a massive engineering challenge. To ensure the crew survive, Orion must be the safest spacecraft ever built. Saving time and money, engineers have borrowed hardware and software from the Space Shuttle program, which launched 135 missions across 30 years.
The Space Shuttle was intended to be a launch vehicle that is mostly reusable, can be fairly cheap and readily available.
But engineers have also forensically examined its catastrophic failures in the hope that costly and deadly mistakes may never be repeated.
One minute, 15 seconds, velocity 2,900 feet.
Big smiles today.
On the morning of January the 28th, 1986, Space Shuttle Challenger was given the go-ahead for launch.
Commander Dick Scobie, followed by Mission Specialist Judy Rusk.
The mission was a magnet for media attention.
Pilot Mike Smith, followed by Krista McAuliffe, teacher in space.
Amongst the 7 astronauts was the first school teacher chosen to go to space, Krista McAuliffe.
Still doesn't seem real that I'm going to be able to go with these guys. I'm excited.
So, on the morning of the 28th of January, there was a lot of excitement in the air. At the moment of launch, everything appeared normal.
But rocket engineers were already harboring grave concerns. Florida had experienced unseasonably icy conditions, dropping below -3 degrees Celsius overnight. Air temperatures were at a record low for a space shuttle launch. They feared the cold snap could compromise rocket booster joints. Rocket boosters are made up of stacked segments. Between each segment, inside the joints, are rubber O-rings. Each one is more than 11 meters in circumference and more than half a centimeter thick.
An O-ring is a pressure seal designed to stop hot gases escaping and potentially causing damage to the structure around it.
So at T0, that's when you light the solid rocket boosters, which are extremely powerful. You know, it's like just a huge explosion with this, solid propellant that ultimately you release the launch clamps and then you launch. So that is certainly a stressful time, especially when you think about the O-rings, the joints on the solid rocket motors, where you've got compressive force because you've got this weight by the force of gravity, but now you've got this force pushing up.
The O-rings are crushed during liftoff. If they don't fully expand again, there's a lethal gap left in the joint.
T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
73 seconds after liftoff, Space Shuttle Challenger tore itself apart.
1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles.
As horrified family members watched below.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
This image, from 58 seconds after liftoff, captured a visible flame plume coming from the right rocket booster.
Once you lose structural integrity in that particular location, then the thing just starts to come apart because there's so much stress on it. And one flaw in that particular area starts to just cascade into boom.
Some astronauts lived long enough to turn on emergency air packs when the crew cabin tore loose from the orbiter. But they had no way to escape the violent descent. The Challenger disaster was a global tragedy, with hard lessons for the space program.
This was a shocking disaster, something that hadn't been experienced for the space shuttle before, and lots of questions had to be answered.
The most crucial lesson was never to downplay safety risks. O-rings for rocket boosters were also redesigned, but there were other major safety issues to address.
Even if they could have ejected, they actually had no safe way. There was no way of escaping the space shuttle if something was to go wrong.
3, 2, 1, boosters in ignition.
To avoid another disaster, Orion needed a dedicated crew escape system. The Orion spacecraft sits on top of the rocket, making it less likely to be harmed in an explosion. But its most important safety feature sits above the crew module. The Launch Abort System, an emergency escape vehicle which can activate within milliseconds.
So, if those astronauts see weird sparks and they think this is not right, they are able to choose for that capsule to jettison away from that rocket.
The LAS can rapidly pull the crew capsule clear of danger. But it must work absolutely perfectly.
Five, 4, 3, 2, 1, ignition. As you will see, Minotaur launch vehicle is carrying an AA-2 launch abort system for a full stress test.
Launching aboard a booster, the LAS and a test version of Orion are rocketed up to an altitude of 31,000 feet at more than 1,000 miles an hour.